Good morning, parents and learners. Welcome back to our Valenzuela Facebook Live in Mathematics 7. Before we start, make it sure that your module, notebook, and pen are with you. For today's lesson, we will discuss the operation on rational numbers. This is based on the Department of Education's most essential learning competencies for the academic year 2021 to 2022. At the end of our discussion, you should be able to recall rational numbers, perform operations on rational numbers, and solve problems involving operations on rational numbers. We will start our lesson today with problem solving. Last week, Royvin spent 3/10 of his weekly allowance on school materials, 9/20 on internet load, and the rest for his savings. What fraction of his allowance did he save? How are we going to solve this problem? Let us always remember that in solving a problem, it is important to have a strategy. When I solve a problem, I always use Polya's problem-solving strategy. It contains a 4-step procedure. The first step is to understand the problem. Second is to devise a plan. This is where you need to come up with a way in solving the problem. It can be through the use of equations, diagrams, or charts. Next is to carry out the plan, or the solving process itself. And the last step is to look back or to check and interpret the result. Basically, we need to check the result to see if our answer makes sense. If that is so, it is the time that we will interpret our answer. Going back to our problem, it is stated that Royvin spent 3/10 of his allowance for his school materials, 9/20 for his internet load, and the rest for his savings. So, the question here is, how is his savings represented in fraction form? Let us now carry out our plan to solve this problem. We can represent the given ideas through equations. Let us use x to represent his savings. For us to find the value of x, we just need to subtract the sum of his expenses to the whole allowance. It will be x is equal to 1 minus the sum of 3/10 and 9/20. The next thing that we need to do is to carry out our plan or to solve our equation. We can easily solve this problem if we know how to add fractions. Let us now discuss how to perform operations on rational numbers. From our problem, we are given with rational numbers. Remember that when we say rational numbers, these are the numbers that can be written in the form of a/b, where a and b are integers, and b is not equal to 0. And from our problem, we need to add 3/10 and 9/20 for us to solve our equation. So, how can we add those fractions? In adding two rational numbers in the form of a/b plus c/b, where b is not equal to 0, we will use these rules. If we have fractions with common denominator, or we call it as similar fractions, we just add the numerators, copy their common denominator, and reduce the final answer to its lowest term. So we can have a/b plus c/b is equal to a plus c all over b. For example, 1/5 plus 2/5. Add the numerators 1 and 2, then copy the common denominator 5. Simplifying, the answer is 3 over 5. But if we are given with two rational numbers with different denominators, or known as dissimilar fractions, a over b plus c over d, where b is not equal to 0 and d is not equal to 0, we can use the butterfly method. So a over b plus c over d, first, multiply the numerator of the first fraction to the denominator of the second fraction. Thus, we have AD. Then, add the product of the denominator of the first fraction to the numerator of the second fraction. Thus, we have BC. Lastly, the denominator will be equal to the product of the denominator of the two fractions. Thus, we have BD. For example, 2/3 plus 4 over 7. Applying the butterfly method, first, multiply 2 and 7, then find the product of 3 and 4, then multiply the denominators 3 and 7. Simplifying, it will become 14 plus 12 all over 21. Simplifying it further, the final answer is 26 over 21. Let us have another example in the form of a word problem. Diana is planning to cook chicken adobo and make vegetable salad with grilled chicken breast. She needs 3 and 2/3 kilos for chicken adobo and 1 and 5 over 8 kilos for vegetable salad. How many kilos of chicken does she need? We will use Polly's problem-solving strategy. First is to analyze the problem. Diana needs 3 and 2/3 kilos for chicken adobo and 1 and 5 over 8 kilos for vegetable salad. The question is, how many kilos of chicken does she need? Now, let us make a plan to solve this problem. We can represent the given ideas through equations. Let us use x to represent the number of kilos of chicken that Diana needs. For us to find the value of x, we just need to add the number of kilos of chicken for adobo and the number of kilos of chicken for vegetable salad. It will be x is equal to 3 and 2/3 plus 1 and 5 over 8. The next thing that we need to do is to carry out our plan or to solve our equation. X is equal to 3 and 2/3 plus 1 and 5 over 8. Add first the two whole numbers, which are 3 and 1, and the sum is 4. Next, add the two fractions using the butterfly method. It will result to 2 times 8 plus 3 times 5 all over 3 times 8. The product of 2 and 8, the result is 16, plus the product of 3 and 5, which is 15, all over 3 times 8, which is 24. Adding 16 and 15 will give us 31. Therefore, we have 31 over 24. Simplifying 31 over 24 as mixed number is 1 and 7 over 24. Adding 4 and 1 and 7 over 24 is 5 and 7 over 24. This means that Diana needs 5 and 7 over 24 kilos of chicken for her adobo and vegetable salad. The subtraction of rational numbers with same denominators is the same in addition of rational numbers, but instead of adding, we subtract. A over b minus c over b, where b is not equal to 0. Simply subtract the numerators, copy the common denominator, then reduce the final answer to its lowest term. So we can have a over b minus c over b is equal to a minus c all over b. For example, 4 over 5 minus 2 over 5. Subtract 4 and 2, then copy the common denominator 5. Simplifying, the final answer is 2 over 5. To subtract two rational numbers with different denominators or dissimilar fractions, a over b minus c over d, where b is not equal to 0 and d is not equal to 0. We can also use the butterfly method. A over b minus c over d. First, multiply the numerator of the first fraction to the denominator of the second fraction. Thus, we have AD. Then, subtract the product of the denominator of the first fraction to the numerator of the second fraction. Thus, we have BC. Lastly, the denominator will be equal to the product of the denominator of the two fractions. Thus, we have BD. For example, 2/3 minus 4 over 7. Applying the butterfly method, first, multiply 2 and 7 minus the product of 3 and 4 all over the product of the denominators 3 and 7. Simplifying, it will become 14 minus 12 all over 21. Simplifying it further, the final answer is 2 over 21. Another example is 9 and 5 over 6 minus 4 and 1 over 5. Subtract first the two whole numbers 9 and 4, and the difference is 5. Next, subtract the two fractions 5 over 6 and 1 over 5 using the butterfly method. So we have 5 multiplied by 5 minus 6 multiplied by 1 all over the product of 6 and 5. Simplifying, we have now 25 minus 6 all over 30. The difference of 25 and 6 is 19. Therefore, we have 19 over 13. Adding 5 and 19 over 30 will give us 5 and 19 over 30. Let us now proceed to multiplication of rational numbers. A over b times c over d, where b is not equal to 0 and d is not equal to 0. In multiplying rational numbers, we simply multiply the numerators, multiply the denominators, then reduce the final answer to its lowest term. So we have a over b times c over d is equal to ac over bd. For example, in finding the product of 3 over 7 and 2 over 5. Multiply the numerators 3 and 2, then multiply the denominators 7 and 5. Simplifying, 3 times 2 is 6, and 7 times 5 is 35. Therefore, the final answer is 6 over 35. Let us have another example. The product of negative 4 over 9 and 3 over 5. Multiply the numerators negative 4 and 3, then multiply the denominators 9 and 5. The product of negative 4 and 3 is negative 12, and the product of 9 and 5 is 45. Get the lowest term of negative 12 over 45 by dividing both numerator and denominator by its GCF, or the greatest common factor, which is 3. Simplifying, it is equal to negative 4 over 15. Let us proceed to the last operation, which is division of rational numbers. In dividing rational numbers, we need to find the reciprocal of the second fraction, multiply the fractions, and reduce the final answer to its lowest term. So we have a over b divided by c over d, where c over d is the second fraction. A over B times the reciprocal of C over D, which is D over C, or simply AD over BC. For example, find the quotient of 2 over 5 and 3 over 7. Applying the rule in division, it will become 2 over 5 multiplied by the reciprocal of 3 over 7, which is 7 over 3. It is equal to 2 times 7 all over 5 times 3. Simplifying, the final answer will become 14 over 15. Another example is the quotient of 5 over 7 and negative 3 over 4. We have 5 over 7 times the reciprocal of negative 3 over 4, which is negative 4 over 3. Next, multiply the numerators 5 and negative 4, and multiply also the denominators 7 and 3. Simplifying, it will give us negative 20 over 21, or negative 20 over 21. Since that we already know how to operate rational numbers, we can now solve our problem. Let us use x to represent his savings. For us to find the value of x, we just need to subtract the sum of his expenses to the whole allowance. It will be x is equal to 1 minus the sum of 3 over 10 and 9 over 20. Applying the rules in order of operations, we need to simplify the expression inside the grouping symbol. Let us add the two fractions using the butterfly method since they are dissimilar fractions. Multiply 3 and 20, then add the product of 10 and 9. For the denominator, multiply 10 and 20. Simplifying, it is equal to 60 plus 90 all over 200. Simplifying it further, we can have 150 over 200. 150 over 200 can be simplified by getting the lowest term. The two numbers have greatest common factor of 50. Dividing 150 over 200 by 50 over 50 will give us 3 over 4. Now, we have x equals 1 minus 3 over 4. Whole number 1 can be written as 4 over 4, since it is still equals 1, and it will be similar to the fraction 3 over 4. So it will become 4 over 4 minus 3 over 4. Apply the rules in subtraction of similar fractions. We have x equals to 4 minus 3 all over 4. Simplifying it, the value of x is 1 over 4. This means that Roy Vin saved 1 over 4 of his weekly allowance. Let us play the reaction game. Solve the following problems carefully. You need to answer them within 15 seconds. Choose from heart, like, or haha. That corresponds to the correct answer. You may type your answer on the comment section or simply hit the react button. Are you ready? Let's start. For question number 1, 5 over 13 plus 6 over 13. Is it heart, like, or haha? Your 15 seconds starts now. If your answer is like 11 over 13, that's great. How did we come up to 11 over 13? Add the numerators 5 and 6 and copy the common denominator 13. The sum of 5 and 6 is 11, then copy the common denominator 13. The answer is 11 over 13. For question number 2, 4 over 5 minus 3 over 8. 17 over 40 for heart, 15 over 40 for like, and 12 over 40 for haha. Type your answer on the comment section or hit the react button. 15 seconds, go! The answer is heart 17 over 40. Good job! For the solution, using the butterfly method, 4 times 8 is 32, minus 5 times 3 is 15, all over 5 times 8 equals 40. 32 minus 15 is 17, therefore, we have 17 over 40. Question number 3. 3 over 5 times 7 over 6, is it heart, like, or haha? Timer starts now. The answer is heart 7 over 10. Very good. 3 times 7 is equal to 21. 5 times 6 is 30. Get the lowest term using GCF. 21 divided by 3 is 7. And 30 divided by 3 is 10. So we have 7 over 10. Fourth question. 2 over 9 divided by 4 over 3. 8 over 27 for heart, 6 over 11 for like, and 1 over 6 for haha. Type your answer on the comment section or hit the react button. 15 seconds, go! The answer is haha 1 over 6. Great job! The solution is 2 over 9 times the reciprocal of 4 over 3, which is 3 over 4. 2 times 3 is 6, and 9 times 4 is 36. Getting the lowest term, we have 6 divided by 6 is equal to 1, and 36 divided by 6 is 6. The answer is 1 over 6. Last question. A basket is full of apples and oranges that weighs 6 and 3 over 5 kilos. If the basket and apples weigh 3 and 1 over 3 kilos, what is the weight of the oranges in the basket? Is it heart, like, or haha? Your 15 seconds starts now. The answer is heart 3 and 4 over 15. Good job! 6 and 3 over 5 minus 3 and 1 over 3. 6 minus 3 is 3. Subtract the fractions using butterfly method. We have 3 times 3 minus 5 times 1 all over 5 times 3. Simplifying the grouping, it gives 9 minus 5 all over 15. Simplifying further the grouping, the answer is 4 over 15. Adding 3 and 4 over 15 equals to 3 and 4 over 15. Let us sum it up. To add similar rational numbers, add the numerators, copy the common denominator, then reduce the final answer to its lowest term. To add dissimilar rational numbers, we can use the butterfly method. First, multiply the numerator of the first fraction to the denominator of the second fraction, thus we have AD. Then add the product of the denominator of the first fraction to the numerator of the second fraction, thus we have BC. All over, the denominator will be equal to the product of the denominator of two fractions, thus we have BD. To subtract similar rational numbers, subtract the numerators, copy the common denominator, then reduce the final answer to its lowest term. To subtract dissimilar rational numbers, we can use also the butterfly method. First, multiply the numerator of the first fraction to the denominator of the second fraction. Thus, we have AD. Then, subtract the product of the denominator of the first fraction to the numerator of the second fraction. Thus, we have BC. All over, the denominator will be equal to the product of the denominator of the two fractions. Thus, we have BD. In multiplying rational numbers, we simply multiply the numerators, multiply the denominators, then get the lowest term of the final answer. In dividing rational numbers, we need to find the reciprocal of the second fraction, then go back to the multiplication rule. Reduce the final answer to its lowest term. In problem solving, we can use Polya's problem-solving strategy. First, understand the problem. Second, devise a plan. Third, carry out the plan. And lastly, look back. The first question is coming from a random student. What is the proper way of writing the final answer in rational numbers? The proper way of writing the final answer in rational numbers is by mixed number or improper. Let us have another question from a random student. Is the butterfly method the only way to add and subtract dissimilar fractions? There is another way of adding and subtracting dissimilar fractions, which is getting its least common denominator, or the LCD. For your home learning task, answer what's more. Try this on page 25 on your mathematics module. This is Miss Annilyn C. Estayo. I hope you've learned a lot today. Have a blessed day, everyone.